Let's take a look at problem 10.3.33. And it really is about, I want to emphasize kind of the interpretation of rejecting or not rejecting the null hypothesis. So here's the setup. You could take a look at this problem here. The null and alternative. We're checking again to see from the random sample, we have 37 students, the mean 106.3 and 13.5 standard deviation. Those values again are the sample data, and we want to perform a test here where they're wondering if the IQ is greater than 103, and that's why the alternative is 103, and then we have the sample data to try to test these claims. And so again, you can see here with this given information here, the director's testing if the sample data provided evidence that the score is actually greater than 103. That's what we're testing here. You run the test, you get a t-statistic. Again, this would be t-stat since it's a mean value. Your p-value is 0.073. It's greater than, so we are not going to reject. Remember, because this probability is not small enough. If the p is low, the null must go. It's because did we observe something unusual? What we observed had a 7% chance of happening, and so from the sample data we observed, so that's not low enough for us to reject the null hypothesis, so we do not reject the null hypothesis, and so there's not sufficient evidence. You change the situation to 104 here, given this, if we were testing that as our value, and then you get a bigger p-value, and again, we have that same interpretation, do not reject. Again, 105, you will see the p-value gets bigger and bigger as our test value is increasing, because remember our sample is 106, so it's more likely that it's not greater than 105. Right, this is sample data. We're interested in the population proportion, the population mean. And then do not reject. I think the hard part is this last part here, part D. One should not reject the null hypothesis, right? One should not reject rather than accept, because if you accept, what we're saying is the null hypothesis is true. And again, that's similar to us saying not guilty. Doesn't really mean innocent. It just means we didn't have enough evidence to say you were guilty. And so we do not accept, because if we were accepting, then this indicates that the population mean is some value, right, on our null hypothesis, like for the first one. We're saying that it equals 103. If we accept it, we're not accepting it, right? And so the same data have been used to conclude that the population mean is 3 different values. In this case, we notice we did not reject it 103, 104, 105. We didn't reject it any of those. So we're not saying that it is 103, 104, 105. What we're saying is we cannot reject that it is one of those, right? And so if we do not reject the null hypothesis, this indicates that the population mean could be one of those values or some other value. We're just not ruling them out as a value of the population mean. Therefore, accepting the null hypothesis can lead to contradictory conclusions, because if we accept it in all of those cases, 103, 104, then we're saying it's all of those values, but it's not. We're just saying that we cannot reject that it's one of those values.